Hey everyone, today we're going to pull back the curtain on a set of instructions in the ARM architecture that are absolute game changers for performance. Load, store, multiple. Think of them as this incredible shortcut for making your code run way faster and more efficiently. But, like any good shortcut, you got to know the rules of the road.
So here's the plan. First, we'll see exactly why these instructions even exist. Then we'll get into the shortcut itself, figure out how it navigates memory, and explore its different modes of operation. After that, we'll cover a few key rules and quirks, and then wrap it all up with a nice, simple takeaway. Sound good? Let's dive in.
Okay, so at the very core of what a processor does, it's constantly shuffling data around, moving it from memory into its own super-fast storage spots called registers. The problem is, if you do that one little piece at a time, you end up with a serious data traffic jam.
Just look at this. On the left, loading one register. Simple enough. But on the right, just to store 4 registers, you need 4 totally separate instructions. This is what we mean by the slow way. Every single one of these lines costs processing time, and it makes your code bigger and kind of clunky. It works, sure, but it is a major bottleneck, especially when you need to move a lot of data at once.
This is where the really smart people who designed the ARM architecture came up with this brilliant, elegant solution, a powerful shortcut that just cleans up this whole data-moving mess. And here they are. Load multiple, or LDM, and store multiple, or STM. The idea is so simple, but it's incredibly powerful. Instead of writing a separate command for every single register, you just use one command to grab or save a whole block of them all at once. And the payoff is huge. Look at this, we've gone from 4 instructions down to just 1. That's not just a small tweak. We're talking about code that runs faster, is physically smaller, and frankly is just so much easier to read. It's a massive win all around.
And believe me, this isn't just some academic exercise. These instructions are the workhorses of the modern CPU. Every time a function is called, you need to save the current state. LDM and STM get that done in a flash. They're absolutely essential for everything from handling system interrupts to switching between the apps on your phone.
Okay, so we know what these instructions do, but the real magic, the secret sauce, is in how they do it. And that all comes down to something called addressing modes, which is really just a fancy term for how the instruction finds the right spot in memory. Which leads to a pretty important question, right? With all this data flying around, how in the world does the CPU know where to start loading from or storing to? It needs a starting point, like a bookmark in a massive, massive library. And that bookmark is called the base register. It's just a regular register that's holding a memory address, our starting point. The CPU then takes that address and adds a little offset to it to figure out the exact location for the data transfer. This little guy is the foundation for everything we're about to cover. All right, this is where we get into the really cool part. There are 3 main strategies for using that base register, and really getting the difference between them is the key to unlocking how all this works.
First up, pre-indexed with write back. Now, I want you to notice one tiny little thing at the end of the instruction. That exclamation mark. It might seem small, but that symbol is a huge deal. It's a direct order to the processor, telling it to update the base register after it's done.
So the sequence is what's really important here. Step 1, you figure out the new address. Step 2, you go to that new address and do your load or store. And step 3, because of that exclamation mark, you write back that new address into the base register. You've officially moved your bookmark. Next up, we have pre-indexed without write back. Now, take a look. What's missing? Yep, the exclamation mark is gone, and taking that one character away completely changes that final step. The first 2 steps are exactly the same. Calculate the address, then go access the memory. But this time, the base register is left completely alone. Your bookmark stays right where it was. This is perfect for when you just want to take a quick peek at some data nearby without losing your original spot. And for our final mode, post-indexed, we're going to flip the whole process on its head. Instead of calculating a new address first, this time we access the memory right away, at whatever address the base register is already pointing to. See the difference? The order is totally reversed. First, you access the memory. Then, after the data is all moved, you calculate the new address and update your base register. It's like reading the page your bookmark is on right now and only then moving it to the next page. Okay, so we've got the main ideas down. Now let's talk about a couple of, let's call them quirks, and some really important rules you have to know when you're working with these instructions.
So here's a classic head-scratcher that gets a lot of people when they're starting out. If you look at the ARM instruction set, you'll see commands to load a signed byte or a signed half word, but you'll never, ever find an instruction to store a signed byte. So what's up with that?
Well, the answer is actually really elegant and simple. When you store something, you are just writing a pattern of raw bits, ones and zeros, into a memory location. The memory system itself has no idea if that data is supposed to be signed or unsigned. It doesn't care. It's just storing bits. So having a special store signed instruction would be totally redundant. It would do the exact same thing as a regular store. Okay, one more little rule you gotta know about. ARM processors have this amazing feature called a barrel shifter. It can do really complex math on an offset value, like shifting bits around, all in a single tick of the processor clock. It's incredibly fast. But, and it's a big but, you can't use this powerful tool with instructions that are only loading or storing parts of a word, like half words or signed bytes. It's just one of those design trade-offs you have to keep in the back of your mind.
All right, we have covered a ton of ground here. We've gone from the core problem all the way through the 3 main addressing modes and their little quirks. So let's boil it all down into one final super clear summary. This table right here is your ultimate cheat sheet. For both pre-index modes, you access memory at the base address plus an offset. The only difference is whether you update the base register, and that's all controlled by the exclamation mark. For post-index, it's the other way around. You access memory at the base address first, and then you always update it afterwards. That's the whole game right there. So, there you have it. The LDM and STM instructions are just a fantastic example of smart, efficient design. A really clever answer to a very common problem. And it kind of makes you wonder, doesn't it? What other ingenious little shortcuts like this are hiding in plain sight, making all the devices we use every day just work?